This is episode 57 of the Web Platform Podcast. I'm your host today, Erik Isaksen, and on the panel we have Justin Ribeiro.
Hello, wonderful people.
And Chetan Karande.
Hi, everyone.
And our guest today is Jay Oster from, did I pronounce that right?
Oster, yeah.
Oster. My apologies. Jay Oster from PubNub. You want to introduce yourself?
Hello, sure. Yes, as you said, my name is Jay Oster, and I'm a platform developer for PubNub. I do a lot of the backend stuff. Most of my backend is in Python, to be honest with you, but I do love the front end, and in my spare time, I develop HTML5. It's pretty fitting.
Okay. And you work on some backend and security, right? Some of this?
Yeah, I do. My main the main project that I developed for PubNub is the PubNub Access Manager, which handles all of our authorization. So we have this authorization security layer, and it allows us to make fine-grained access control rules, which in the case of, say, an application like a chat or a game, our customers can grant and revoke certain access to their end users. So that's kind of the system that I work on. And there's some cryptography involved with that, in particular the signing of requests. So all of our requests need a digital signature so that we can validate that the request is made by our customer server rather than one of their users to grant and revoke permissions. Yeah, so that's my main focus with our backend security stuff.
Okay. And our topic today is mostly about web crypto. So can you explain what that is and why we should or shouldn't use it?
Yeah. I think actually the web crypto standard is probably one of the more important APIs to come out of the web browser standardization efforts. Even as important as, say, SSL and TLS were in the late 90s or so, primarily because it gives application developers the ability to do their own and hashing, end-to-end cryptography, without introducing any kind of roll your own kind of bugs, security issues or abilities that come with that. So really the importance can't be understated of this API itself. And yeah, I don't know, it's really easy API to use. There are only a few different methods available, so it's great stuff. Really cool.
So what is it though? I mean, what like is it like some blob of binary data? Is it like a hash, or like how does it work in the browser?
Well, it provides an API that you can use with the typed arrays. So instead of, say, providing any kind of arbitrary data, you would just give it a typed array. Usually it would be like an array of 8-bit unsigned bytes. So in something like a string, it would be an array of Unicode characters, and they're not necessarily bytes. They're in JavaScript anyway, it's 16 bits per character, and that gets really weird with certain big characters like emoji. So you would have to normalize that down into like a UTF-8 with different APIs that are available for that. It would create this 8-bit byte array for you, and then you can encrypt the byte array. You can hash over the byte, sign it. Just the different functions that are in web crypto would allow you to do that. And yeah, so that's kind of what it is in a in a nutshell. It just uses the standard JavaScript typed array.
Okay, and what are the use cases that you've seen?
Use cases are, wow, there are so many of them.
What are the most interesting, I should say?
Yeah, I would say one of the most interesting, especially for our customers who develop things like a chat application. They, even though we provide this authorization layer, we don't necessarily have authentication built in, and there's a very subtle but very important difference between the two. The authorization is, what are you allowed to do, and the authentication is who are you. So even though we provide that what are you allowed to do, we still don't necessarily know who you are. So in the case of like a chat application, the end users are typically sending messages back and forth between other users. It could be a public channel, it could be private messaging. But the PubNub data stream network itself doesn't really have any notion of who these users actually are. Just that they have an authentication token that was provided by, say, OAuth, Twitter API, or what have you. So what the web crypto allows you to do in this situation is provide a public key infrastructure using something like, say, SKI. It's a very simplified form of the same kind of PKI that's used for SSL. It gives you an asymmetric encryption, which means that a user, say myself, has a private key and a public key, and a user like yourself also has a key pair, private and public. And the private key, that stays with yourself, that doesn't go anywhere, but the public key goes to everyone, so everyone is allowed to see this public key. And the interesting point about the asymmetric encryption is it really allows you to validate messages, in the sense that with my private key, I'm able to decrypt messages that are meant for me. That is, anyone in the world can encrypt a message for me using my public key, if that makes sense. And since I only have my private key, I'm the only one who's able to decrypt those messages. And this whole infrastructure allows a form of digital signature where my message can be decrypted using my private key, and then anyone in the world can re-encrypt that message and validate that the bits that come out of that decryption are what I say it is. And I should probably go into a little bit more detail about that, since this is a really complicated topic. So we have to, instead of taking the entire message, because it could be a very long paragraph or whatever, you would want to compress it down. So that would be a hash function. Web Crypto provides a hash function for that. The hash functions are one-way encryption. So given a hash function, you can't reverse it into its original text format and so forth. The hash function itself would then be encrypted. So I have my big blob of paragraph text, and I want to compress that down with a hash function. And then I will decrypt that hash function with my private key. And then this decrypted output becomes my digital signature, which says that for certain, I was the one who wrote this message, and no one else wrote this message. And you can verify that I was the person who wrote it, because you, with my public key, can encrypt this signature and validate that it turns out to be the same as a hash of my original paragraph. So it's really complex, and it's hard to get this stuff right. So that's why web crypto is really, really important. You know, that's why we need this API. It certainly is.
And so far, the browser support, do you know what that is, and the polyfills for this?
Yeah, I do. So I know Internet Explorer supports it since IE 11. However, it's under an MS prefix, and in Edge they removed that prefix. Chrome supports it out of the box since something like, I don't know, 35 or so. Let's see. There's a documentation available on the Mozilla Developer Network. I'll just bring it up here. So Chrome supports it since Chrome 37, Firefox since Firefox 34, Safari since Safari 8. Yeah. And polyfills, I'm not too familiar with those, but I imagine they go, all the way back as far as ES4 browsers even.
Okay, and on server side, probably that's what you use mostly, right, at PubNub or Node. What version of Node supports crypto?
Node support, I'm not sure about that.
Okay.
Polyfills would be used for Node, definitely.
Okay. So it seems pretty useful API. So would it be practical whenever you use traditionally pretty much we're relying on TLS or HTTPS for securing our communication to prevent man in the middle. So would you recommend adding this extra layer all the time, doing crypto for sending all type of data, or is not that performant?
Those are really great questions. So I'll start with the why would I want to use web crypto in addition to SSL?
Mm-hmm.
In my professional opinion, yes, you do want to do this, and this is because even though SSL is available and you can't get people eavesdropping on the communication and so forth, that's not always going to be true. Like a few years ago, we had the big Edward Snowden leak, right?
Mm-hmm.
Where the CIA was actually in cahoots with different service providers, and they were decrypting SSL traffic. So even if you have this SSL TLS layer, it is important to also provide the end-to-end encryption for very sensitive data. And PubNub itself has AES support in all of our client SDKs. And this is one of the encryption algorithms that's available within Web Crypto. So yeah, it's very important that you would want to combine the two technologies. The second question about performance.
Yeah.
This is really, really cool that it's being, the whole cryptography thing is being brought into the browser in native code where it can actually run fast. You have all of these different mathematical transformations that have to happen, and that's really nice and performant in native code, but not so much in the JavaScript layer. Things get a little bit better with the recent just-in-time compilers for JavaScript, but it's still not going to match native performance. So yeah, if you get anything out of it, performance-wise, Web Crypto definitely.
Cool. Another aspect mostly is usability, right? When the security feature comes, people kind of try to trade off the security usability of it. So do you think by any means is it going to affect user experience or usability? Maybe, I don't know, does it prompt for the user passwords when it needs to do encryption, decryption, or does it need to kind of the responses are slower than usual? Do you notice any of those concerns?
So I guess you're asking about whether using this API asks for passwords and that sort of thing?
Yeah, in general, does it impact usability of application, in short?
I see. No, the Web Crypto API itself is more of a generic kind of API, so it doesn't necessarily hook into any kind of a keychain or anything on the operating system, or it's not built with that sort of thing in mind. It's really more for just application level security, cryptography concerns. I don't know if that really answers your question.
Yeah, pretty much.
Okay.
Cool. Great. And I was just looking up, probably this blog article I came across was a few years old, and it was about what's wrong with crypto. And one of the things it mentioned is the web crypto standards itself are pretty loose. I mean, for a reason, they didn't probably specify exact algorithms that should be used, because algorithms are evolving and they wanted to be a little more generic. But that also leaves browser vendors to choose any algorithm they want to use for implementing those APIs. So that creates issue with interoperability of our applications with different browsers. Did you notice any of such issues, or those are taken care of in recent specs? Would you know?
That's interesting. Different interoperability issues. I'm not familiar, and unfortunately, your voice dropped out for about half of that, so I didn't get your entire question.
Okay. So probably I can repeat it if it is okay.
Good, thank you.
Yeah, so the question mainly was just the browser vendors are pretty much free to choose any algorithm they want to use to implement the APIs, and that's where the interoperability concerns were coming. Like, is it still an issue, or it is pretty much not existing issue anymore?
I see. That's a question that I don't actually have an answer for. What I've seen so far is that there are a kind of a minimum viable base of algorithms that are generally supported. Those are the SHA family of hash functions are supported, and the AES family of symmetric encryption standards are supported. For asymmetric encryption, I'm not entirely certain which algorithms are available for those, or what their standardization efforts are.
Right, yeah, that's fair.
So it sounds like the browser support is much better than I had thought before. Why aren't people using this now?
I think they're not using it right now because it's pretty, relatively new. Things take a lot of time to really adopt, especially in the front-end world, where it took so long for us to really get ES5 everywhere, and took a long time for us to get HTML5 with the Canvas API. It's taking a long time to get WebGL out there on all the different UAs that are available. We're going to see the same thing with ES6 and the classes and arrow functions and collections. All these different features that are being implemented in new browsers are not necessarily backward compatible. However, we have different polyfills available for those. And I think that's really going to be the biggest barrier to entry with any kind of new API, including web crypto. But using the polyfills is typically the best way to get the best of both worlds. Whether you get the good native performance and the standardized algorithms and so forth of web crypto itself, or use a polyfill and get at least a little bit of backward compatibility in your browsers.
So what have you seen in the past, or even today, that's some good competitors for this type of cryptography in the browser, or alternatives to using web crypto? What have other people proposed, or what are other people using or doing now?
Let's see. There have been a few different attempts to get different kinds of standardization, well, sort of standardization efforts for cryptography. One that I can think of is the different ways to store different kinds of encrypted information. So, for example, serializing a message into a specific JSON format, and I think one was called uh, JSON Web hash, JSON Web signature, JWS, something of the sort. And so there are different like node libraries uh, for doing these kinds of things. And interestingly enough, I noticed that Web Crypto itself also supports the same kind of serialization formats. So even if you're using, I think it's called JWS, on Node, you can still use the same formats in Web Crypto on the browser.
Well, the
So that's pretty
JWS works with JWT, right? And that's like for identity, usually for using identity, right?
correct. Yeah.
Okay. Sorry, Justin. Go ahead. Okay. All right. I think his mic is having problems.
Yeah.
All right. So yeah, I mean, I don't know a lot about it. I know Christian Smith, who's on the show a lot. He really specializes in a lot of that type of work. And so he's talked about it quite a lot. But web crypto is something we really haven't talked about. What are the misuses of web crypto? What do you don't recommend doing with it?
With Web Crypto itself.
Yeah.
I think there are some ways that you can really shoot yourself in the foot with it. It might be not the easiest thing to come up with a real solid example. Probably
Okay.
things like, just to give you a really silly example, things like the random source in Web Crypto, which is supposed to give you a truly random series of bytes. Often it's going to be better to just use math.random instead of using a truly random source because, well, that could exhaust your random entropy state in your system. Yeah, I don't know. There are different things that you do want to avoid, though.
Cool.
Okay.
So, Jay, would you recommend any good resources that you know about web crypto to get started with?
Yeah, the Mozilla Developer Network has some really awesome documentation on it, but it's just general API documentation, so it doesn't explain things like necessarily how to use it or its best use cases. And for that, I don't have any real solid resources for you. Maybe there are some good blog posts out there. Maybe someone else can chime in if they have any ideas.
Okay.
So how are people who are using PubNub using web crypto that you've seen? What are the implementations that people have done?
Yeah, most of the PubNub customers are using Web Crypto if they're using Web Crypto for doing the public key infrastructure stuff. So the adding the authentication layer on top of PubNub. And yeah, that's a very important piece of the equation for many applications. So it's something that you really can't just kind of sweep under the rug or forget about.
And you said that some of the alternatives would be to use something like JWS, JWT. Like, what's the trade-offs with that? Like, why would I have one versus the other? And why would people create two things that do the same thing? Like, and maybe I'm missing what you're saying about it.
I think it really comes down to the thought that even though JWS is it's already available and it works really well, it's still not it's still not running in the native land, compiled down into machine code statically by a C compiler, kind of native code, which is where web crypto, at least in my opinion, really shines as far as the performance aspect of it. And yeah, that's probably the biggest reason. The JWS and JWT and this whole ecosystem of encryption libraries are really awesome, though, and yeah, it I guess would be a little bit of the performance thing, but also maybe I don't know, maybe there are different kinds of what am I trying to say? Portability issues. So, say if you're sending encrypted, say, ciphertext to a server that might be running Python or Ruby, something that's not JavaScript, it does help to have at least a little bit of something that's a little closer.
All right, I could see that. So, for there's a lot of criticism as far as the specs go. The standards might be a little loose. As you said before, what can lead to these interoperability things that Chetan was talking about? Like, do you know anything further on that?
Yeah, sorry, I didn't catch that one. I guess our Wi-Fi is not the greatest in here.
No, I just asked that the interoperability issues that we talked about before. Is that like have you seen any of your users encounter any of these issues? Like, has anyone contacted PubNub and said, "Hey, we're having these problems"? Obviously, no names, but
yeah. Since I'm not on the support team, I don't get a whole lot of that stuff on my desk exactly. I do at times help out with different support cases, and I haven't seen anything of the sort with different interoperability issues, but one that I can imagine that could be a caveat to avoid is the issue of text representation. That is, in JavaScript, all text is a series of Unicode 16 characters, and you have to serialize that down into UTF-8. If you don't do that, if you don't serialize on both ends to UTF-8, then you really risk causing problems with interoperability, whether it's across platforms, across between JavaScript and a non-JavaScript server or a database or anything of that sort. That I would say is definitely a pitfall that you want to avoid. and it's something that you don't necessarily think of.
So let me play devil's advocate here. Let's say I am a black hat. I'm like trying to mess somebody up with web crypto. Like, what might be some attack vectors I might take to deal with this, and how does web crypto kind of stop that? Because you said it's at native code level, right? So I'm assuming with all of the polyfills and everything, there's probably a lot of holes, but have those holes been fixed? And what would you recommend to prevent attacks? I know it's a lot all at once, so first let's start with what are some attack vectors, and then how would you counter those attacks?
I would say one of the most important attack vectors is probably the storage of your private information. So any kind of secret key, whether that's for symmetric or asymmetric encryption, that secret part, needs to remain secret under every circumstance. So if it's stored to something like local
So I don't add it to
storage,
GitHub or anything, right?
yeah, don't put it out in the wild, please, for sure. But even if it's stored in local storage on your end user's machine, there's really nothing stopping, say, a malicious JavaScript that somehow gets injected into your web application from reading that information out of the local storage and then using it, right?
Yeah.
So the Web Crypto API itself supports a specific kind of function for creating it's called wrapping and unwrapping, so you can wrap and unwrap your key in a secure way. And basically what that does is it takes your private information and it encrypts it with some kind of a passphrase that you provide it. You would provide it by, creating a secret key with a password or something like a password input. And this wrapped key is then encrypted. It's like a nice bundled encrypted blob of meaninglessness, and then that can be stored somewhere. And then when you read that out of your local storage or you read that out of GitHub or whatever, that's when you would prompt the user for their password again. So as a black hat hacker, that's one of the things that I would look for is any situation where I have a key that is stored somewhere, some private information that's stored somewhere that is actually readable. And that's something that you want to avoid.
And then to reverse that, how do I protect myself?
Yeah, to protect yourself, that's where you would want to create a password prompt or a passphrase prompt in your application. So when your user goes to do something that requires the cryptography, even though you have a secret stored somewhere, it's in an encrypted form. And so you prompt the user, please enter your password to decrypt this secret information. And the excuse me, this works really well because the password kind of small, it's easier to remember than, say, a 1024-bit secret key. So yeah, it has a bit of trade-off. There's the usability off and so forth, but as long as you're not storing just the plain text secret key anywhere, then you're relatively safe.
Okay. And it sounds like I was researching JWT recently for a client, and one of the things I liked was that it's just really easy and to do, but I was a little concerned with the translation. So on the client side, if it's JSON, it's usually text. So I found out when it gets decoded, it just shows some general information. It doesn't have your actual key to break things. So, but you still need to store that someplace, and you can't do it in local storage because, like you said, it is pretty dangerous. You can't put it in standard JavaScript cookies. But one of the recommendations I saw with some Angular posts was to store it in a cookie that's not accessible through JavaScript, right? And then pass that back and forth through the headers. So I mean, is this something you recommend with web crypto? Because with JWT, it's yeah, you could do that, but it doesn't really give you the advantage to having like an OpenID server or something like that. So it just depends on your use case.
Yeah, that's a good one. Haven't actually heard of that idea, although I would exercise caution. You don't want to send any kind of secret information in a cookie if you're not using HTTPS.
Oh yeah,
Um,
definitely.
right, right. And even if you are using HTTPS, then you're still kind of at risk for uh, any kind of eavesdroppers who have SSL certificate, or can break that chain of trust. So yeah, I would be very cautious to putting any kind of secret information on the wire for any reason, unless it's encrypted with another password. And uh, yeah, that's pretty much all I can think of at the moment is make
Can
sure
you
that it's secure in some way.
sorry, could you tell us like have you seen what are some examples like we could go to see how web crypto is used now? So if I if I want to start implementing this and working with this, where can I go to look at an example?
Yeah, I don't have any examples for it, unfortunately. Um,
Okay.
all I
Well,
really
what about to
is
learn? Is there like a site, learnwebcrypto.com?
uh, yeah, uh, I'm a big fan of the plain old developer documentation. So Mozilla's MDN is pretty awesome for that. Um, but like I said earlier, it won't tell you exactly how to use it or different use cases, and I don't have any uh, real resources for that either. Um, I mean, apart from a random Google searches, and who knows what quality you'll get.
So definitely PubNub seems to be using it pretty much, and they're pretty happy with it. Would you know any other companies they are using it heavily, just like yours, in general?
Mm, no, I can't think of any, but I'm certain there are different use cases available for pretty much all of the big companies.
Yeah.
Uh, Google, Twitter, Facebook. I mean, there are definitely use cases for the kind of products that they build.
What do you recommend if I have media files or streaming data, even bidirectional streaming data, like how would you handle that? Would you use web crypto or would you use some other um, cryptography?
Mm, wow. I think you can probably get the crypto API to do streaming encryption. Uh, it may not be the easiest thing ever.
Well, is it
Um,
made for that, or am I like sticking a square peg into a
uh,
circle hole?
yeah, no, it's not really made for any kind of streaming data like video or audio um, or control signals or anything of that. It's really
Okay.
made for you have a big blob, a static blob, and then you want to encrypt it. Encryption function returns a promise, so at some point in the future, your promise will resolve, and you'll have this blob of ciphertext. So it's not necessarily made for like streaming. You don't want to encrypt different blocks, all the time.
Okay. How have you seen that handled, or have you not seen it handled that at all? With
Yeah,
as far as like
I
securing that data.
I haven't necessarily seen that. Um, the the support that we have for our JavaScript SDK for AES encryption is it's a non-standard, just an additional library. It's like a crypto.js add-on, and since it doesn't do the encryption asynchronously, it's a little bit easier to do streaming encryption and decryption with it.
Mm-hmm.
But as far as web crypto goes, yeah, it's all asynchronous and probably has a little bit of non-determinant to it.
And I noticed you have a crypto like API that you're using, and what do you primarily use that for? On because it's probably from your application that you work on.
You're talking about the PubNub API?
Yeah. So if I go to PubNub docs,
Yeah.
I did find like some information about cryptography that you guys do for your product.
Yeah, that's
Is that something that's similar?
Yep, it's just the advanced encryption system. So AES is built into all of our PubNub SDKs, and it just allows the end-to-end encryption for all of your data streams. So since we have to support multiple different forms and multiple languages, they can't all be web crypto. And I think it may not even be web crypto in the JavaScript API. I would have to have a look at the source code. It's out there, anyone can. But I don't think it is web crypto at the moment. And that's mostly because it is kind of a new-ish API, and the JavaScript SDK has been around for like 4 years or so.
All right. Chetan, do you have anything else?
No, I think that was pretty helpful. Good to know all about it. So in general, probably there are a lot of APIs. So probably I was just curious if there's someone just starting with it. Would you like to give some idea about what all big building blocks are there, and in general how to start learning about it? How should we approach looking through the docs?
Yeah, the cryptography is a very, very big branch of computer science, and I don't know if it's really going to be something that's easy to jump into for most developers.
Yeah.
Or whether you have to have at least a decent mathematical background to understand most of the basic concepts, or if you're just very motivated and you have passion for security, maybe that's enough. But really, there are some really good books out there that you can read about the different notions of cryptography, and how it's kind of come up to what it is today. The reasons for having asymmetric encryption versus symmetric encryption, and the reason for digital signatures and so forth. Yeah, it's a huge topic. There's lots of material. So yeah, I don't know if it's something really easy for anyone to get into, but for any kind of application where you require security, yeah, it is good to get to.
Cool.
All right.
Awesome.
Well, if people want to learn more about PubNub, about you, what's your Twitter handle? How can people find you or learn more about PubNub and Web Crypto?
Yeah, good. So you can learn more about PubNub, pubnub.com. We're a data stream network, and anything that you can serialize as JSON, we can send to anyone in the world in a quarter second or less. Pretty fun. Check it out. Very simple to use. It's just 2 functions, and it's free to use. So hop in there and give it a shot. As for myself, my name is Jay Oster, and you can find me at Twitter, Codeworks, Kodewers. And I'm usually tweeting about either my game engine that I develop, Melon.js, or different kind of projects that I like to mess around with. Yeah. Sorry, web crypto. Yeah, if you can stomach it, read through the W3C spec because it has all the information. It's not easily digestible, but it's all there, including a lot of the pitfalls and things that you have to watch out for. And there's a huge wealth of information on Amazon. Pick up any book on cryptography. It'll probably do you just good.
Awesome. Justin jumped back on for a second.
I did, because hopefully my mic works now.
It does work. It does work.
Oh, technology!
We've been waiting the entire episode for this.
I love when technology just completely fails. I'm blaming. Actually, I'm blaming the fact that the power is blipping here at the moment.
You guys are just dealing with too much crazy hardware over there. That's what it is.
Yeah, I'm. It's too insane at the moment.
Do you have any last-minute questions?
Last-minute questions on web crypto. Are developers going to get it? Like, honest question. Like, are web developers going to understand? Because, developers, crypto is hard. Like, I think we can all agree that, no matter how simple you try to make things, you look at the web API or web crypto API footprint, and you're like, all right, it's pretty good. But I've also dealt with crypto before, and so it doesn't terribly terrify me. But are developers going to be terrified? Because it is, the learning curve, if you've never actually had to deal with crypto, can be pretty harsh.
Completely agree. And yeah, I don't think it's going to make it any more sugar-coated or delicious. And I don't know if it's actually going to make it easy to use. I'll be honest with you. There are more ways to shoot yourself in the foot with cryptography than there are to make your application secure. That's just the nature of it. So yeah, the footprint is small. It's only 10 functions. Using those functions effectively is a real challenge. And I guess really the only way you can solve that is through education.
I mean, do you think that, with that education, with the, will people, things change so quickly? There's been a lot of complaints that, the web changes too quickly lately, which I disagree with. I think it's lovely that the web platform continues to grow epically every day now. But,
Here.
With the idea of cryptography, though, I mean, you have it is a bit of a minefield. You look at, I love basic cases, and I want to run a digest on a file and just verify my hash. Seems pretty simple, might work lovely for a starter case of things, but once you start getting into PKI and everything else and public privates, it becomes, I mean, obviously I agree. I don't think you can sugarcoat it, but I can only hope that people continue to learn it, because it is a very powerful API with that you can do some just amazing things. And with things like WebRTC and peer-to-peer, where you're not going through servers, things like web crypto seem to have significant impact, where you are going to need these things.
Yeah, come on. I mean, it's bad manners to show your privates in public.
That's what the police officer continues to say.
You bring up a good point, though, with WebRTC. I didn't even think of that.
Well, peer-to-peer wise, yeah. I mean, think about it. I mean, you've got with the Bluetooth API and on the horizon, things like WebNFC, which has its own crypto, which ideally will do the same sort of cryptographic functions we've come to expect from other types of NFC and implementations. Like you do, There are more chances where you're not on the internet, where you have a web browser that is doing very desktop things that you need it to interact with stuff, and you're going to need crypto for that. It seems like a solid fit for expanding use cases where things are not so centralized.
Yeah, totally, and that's really one of PubNub's core services is providing peer-to-peer data streaming. Which is why we heavily suggest that cryptography be implemented in pretty much everything that uses PubNub. But now on the flip side of what you said about the web platform changing so often, cryptography itself doesn't necessarily change so often. It does evolve from time to time, right? We get better algorithms show up, but it's really more of a slow process. And what we know about the security implications of different algorithms, so forth, you know, that also doesn't change too often either. So even though we have this real core set of different algorithms available to with web crypto, it's not like those are going to evolve very much over the course of time.
Sure, and I think it'd just be simply lovely to be able to PGP encrypt a message in my browser without extensions and plugins. I mean, for someone who used to do it quite a bit way back when, like to have that in a browser with no basically plug-in architecture overhead, something that is native to that browser it's a lovely sort of concept. And I agree, cryptography is not something that necessarily changes quickly overnight. The web platform these days, with so many APIs on the horizon, so many things that sort of deal with the extensible web manifesto, this idea of low-level APIs feeding, the higher-level abstractions and the sugar that we all like. It's a lovely time to be a web developer.
Yeah, the use cases will definitely change. Maybe crypto will adapt to that, or maybe it doesn't need to.
I think I'm smart enough to know that I don't know enough about crypto to even begin to say you should change that. I don't know.
All right, is that it?
I've said my spiel after I've been gone for like half the episode.
All right, good. We're done with you. All right. Well, thank you, Jay. It's been a pleasure.
Thank you.
And next time we have you on the podcast, you will have written a canonical source for web crypto, a bunch of blog posts, and an example app that we can showcase, right? I'm going to contact Steven and have him put you on it.
I'll be way more prepared next time. Totally.
No, this has been good. It's been educational. Security is not easy in general, and on the web, because of all the moving parts and all the rapid change, it's definitely a challenge.
Sure.
So, well, thank you very much.
Sure. Thank you. Thanks, Jay. That was helpful.
And we will talk to you soon.
Cool. Looking forward to it.
Okay. If it'll stop. There.